Okay, so in 4.4 we're going to be finding all the possible rational zeros of a polynomial. So first I start by explaining a rational number, and basically a rational number is a real number that can be written as a quotient of an integers, which means a fraction. So a rational number can be a fraction. So the rational zero theorem says if a polynomial p of x has integer coefficients, then every rational zero of p of x is going to be of the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So to find all the possible rational zeros of the polynomial, you find all the possibilities of any p over q. So here for this one, I'm going to determine all the possible rational zeros for this polynomial p of x. So I need to find all my possible p's, which is a factor of the constant, which is 6. So that's going to be 1, 2, 3, and 6. And try to keep these in order from least to greatest. And then my factors of my leading coefficient, which is going to be my q. My leading coefficient is just a 1, so that's just going to be 1. So that means all the possibilities of p over q is going to be plus or minus for each of them. 1 over 1, which is just 1. 2 over 1, which is 2, plus or minus 2. 3 over 1, plus or minus 3. And then 6 over 1 plus or minus 6. So this is the list of all the possible rational zeros. And then sometimes it's going to ask me to test the zeros to find the ones that are actually zeros and write it in factored form. So I'm going to use synthetic division to test all these possible zeros, and I'm going to start with positive 1, and I have none of my coefficients are missing: 1, -1, -5, -1, -6. So bring the 1 down, multiply with 1, that becomes 0. 0 times 1 is 0. Add, that's -5. Multiply with 1, -5, -6, multiplied with positive 1 is -6. So that one does not work, because that does not cancel out. That would be -12. And in order for it to be a 0, remember it has to have a remainder of 0. So now I'm going to check -1. Same coefficients. So I bring the 1 down, multiply with -1. Combine, multiply with -1, that becomes positive 2. Combine, positive 3, and that one does not work either. I'm going to go on to the next page. So I have my list of possible. I've checked positive 1 and -1. I'm checking positive 2 now. So that's 1, 2, 1, 2, -3, -6, -7, -14, and that does not work either. So now I'm going to check -2. You need to keep going until you can get it to a quadratic. That becomes positive 6, positive 1, -2, -3, positive 6, and this one does work. So now since this one works, I have a cubic. X cubed minus 3x squared plus 1x minus 3. And I'm going to keep going with my possible zeros. So now I got to try positive 3. But instead of using these same coefficients, I'm going to now use my new coefficients. So that's a 1, -3, 1, -3. So that's 1 times 3 is 0. Times 3 is 0. Sorry. Combine those, that's 1, positive 3, and 0. So this one works as well. That works, and this one works. And what I have left is x squared plus 1 now. Once it's in a quadratic, you can factor it. So if this is able to be factored, you factor it. X plus 1 is not, so I'm just going to leave it like that and write my other factors, which from this one here is going to be x minus 3, and from this one here is going to be x plus 2. So this is my factored form. I'm going to do the same thing for this one. Let me list my possible p's, which is plus or minus 1 or plus or minus 2, the factors of 2, my constant. So now I'm going to find my factors of my leading coefficient, which is 15. So I have plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So when I'm listing my P over Q, sorry, this should be a cubic here. Didn't catch that. And I have 1, sorry, they're all plus or minus, positive 1 over 1, which is 1. So I have plus or minus 1, plus or minus 2 over 1. Then I have to go to plus or minus 2 over 1, or I'm sorry, plus or minus 1 over 3. Then plus or minus 2 over 3. And then start back, plus or minus 1 over 5, plus or minus 2 over 5, plus or minus 1 over 15, plus or minus 2 over 15. So this is the list of all the possible rational zeros. In this one, I don't need to find 2 of them. I will only need to find 1. So when I start, I'm going to start with positive 1, 15, negative 32, 3, 2, no missing terms. So that's going to be 15, 15, negative 17, negative 17, negative 14, negative 14, negative 12. That doesn't work. So now I'm going to go to negative 1. 15, that's negative 15, negative 47, positive 47, 50, negative 50, that's not going to work either. I'm going to try to stay on this page. Positive 2, $15, $30, negative 2, negative 4, negative 1, negative 2, and positive 2 does work. So what I have left is 15x squared minus 2 minus 1. Sorry, 2x minus 1. And what I can do, now that it's a quadratic, I don't need to keep going. Because I have the quadratic, I can look to factor that. And what that factors into is 3x minus 1 times 5x plus 1. And with this 0, I have another factor of x minus 2. So this is completely factored. If I would have kept going, you would have gotten positive 1/3 to work, and you would have gotten negative 1/5 to work from those two factors. That's all.